Hello everyone. In this video, I am going to talk about data preprocessing in Python. So first of all, what I'm going to do, I'm going to upload a data set. So you have to click on here, click on upload option, and then upload your data set. So I'm using a CSV file and performing data preprocessing operation on it. Once your data set is uploaded, the next step, what you have to do is you have to import all the required libraries. So I'm writing import pandas as PD. In order to run the cell, you have to press shift enter. Once this thing is done, you have to read your CSV file. So df is equals to pd dot read underscore CSV. Now in double quotes, you have to specify your file name. So my file name is company underscore data dot CSV. Next, with the help of head function, we can see the top 5 rows. So df dot head. Now this is my data set. Now, if you want to check out how many number of rows and columns present in the data set, you have to use df dot save function. Next, in order to print the column name, you can use something called as df dot columns function. It will give you list of all the columns present in your data set. Once this thing is done, if you want to check the information about the data set, you have to use something called as info function. So df dot info. So info will give you all the things, which is number of rows, number of column, your column name, their data type, along with non-learn count. Then how many of them are float? So 4 of them are float, 3 of them are integer, and 4 of them are object type. And your memory usage. So my memory usage is 34.6 KB. Once this thing is done, now let us talk about what are the steps that you have to follow in order to check the quality of the data. So the first step that you need to check is check for the incorrect data type. So let me just write it here. Click on text, click on title. So step 1 that you have to do is check for incorrect data types. So in order to check for incorrect data types, you have to use something called as dtypes function. So df dot dtypes function. Now you can see that this is the output it is giving me. As you can see that the advertising column is of object in nature. But when we are doing head function, the advertising column is showing me integer values. So why there is this problem? As you can see that in advertising column, we have hyphen present in this. That's why it is making the column object in nature instead of integer. So what we have to do in order to fix this thing, we have to replace this thing as nan and then remove it out. So first of all, what you have to do, you just have to select it out. So just find out where it is present. So it is present in advertising column. So df advertising, df advertising. Then what you have to replace? You have to replace hyphen. So dot replace. And here you have to write hyphen. So replace hyphen with np dot nan. So what is np here? np is basically a numpy library. So you can import above. So this library is basically used for performing the mathematical operation. So you have to write import numpy as np. Once this thing is done, the next step, what you have to do, you have to convert this column into numerical column. So what I will do, I will write df column name, which is advertising. I will be using pandas function in order to convert this column from object to numeric. So I will write pd dot to underscore numeric. And here I will pass my column name, which is DF of advertising. Now run this out. Now check your data type again. Is it fixed or not? So df.dtypes, you can see that my advertising column is fixed. Now the second steps that you have to do in order to check the quality of the data is check the column names. So you can see that we have one spelling error present in this price column. It is written as pricey here. So step number 2, check for the spelling error in the column names. So if you just write df.columns, it will show you all the list of the columns. Now what I have to do, I have to replace the pricey with price. So the function that I'm going to use is df.rename function. So df.rename your column names. So columns is equals to, my column name is pricey, and I want to replace it with price. So I will write here price. Next, you have to write in place is equals to true. So write in place equal to true. Make sure it is in double quotes. So this is how you fix the spelling error in a column. Once this thing is done, just run this out and check your column name again. So df dot columns. You can see that I have fixed my price column. So this is step number 2, checking for the spelling error in column name. Third step is to check for the spelling error in the column values. Like you can say in each row, you have to check it out. So step number 3, check for spelling error in the categorical columns. So first of all, what you have to do, you have to select out all the categorical columns. So first of all, I'm defining object underscore false variable. Then I'm doing df dot select underscore d types. Now here I will write include is equals to object. Then I will print my column names, which is an object in nature. So you can see that there are 3 columns which are is object in nature. Now what I want to do, I want to check spelling error in each of the values. So I have to run a for loop. So for call in object underscore calls, and I want to apply basically the value count function. So let me just apply value count function here. So print, write f string here, value counts for column name. So let me just write here column name. After that, do value count. So print df call dot value underscore counts. Once this thing is done, let me just run this code. It will show me all the unique values present in each column. So we can see that in self log column, we have some spelling error, like bad is written as BA and good as written as ZW. So what I will be doing, I will be fixing these things. So how to fix this thing? You have to use something called as replace function. So the column name is self log. So select your self log column, df self log, df self log dot replace. So what we have to replace? We have to replace BA with bad and ZW with good. So I'm using a dictionary here. Just write your BA, replace it with bad, and write ZW and replace it with good. Once this thing is done, run this out. Now you can verify this thing, is it correct or not? So what I'm going to do, just copy pasting the codes. So I am just copy pasting the codes here. Now you can see that I have fixed the spelling error in the categorical column. So now there is no spelling error in the categorical column. So this is my step number 3. So let me just write it here. It is step number 3. The next step that I have to do is you have to check for the negative values in a column. So how do you check for the negative values in a column? So let me just write the title is step 4. Check for the negative values in a column. So if you want to find out negative values in a column, what you have to do, you have to use the describe function and look at the minimum. So df dot describe, you can see that we have to look at the minimum. So here we can see that we have minus 120 is present in the price column, which is a negative values. So in order to find out negative values, we do describe function and look at the minimum. So it shows that the price column contain negative values. Now, in order to fix this thing, what you have to do, you just have to select your price column. So df price column. Then you have to apply. Now here you have to apply your lambda function. So let me just write my lambda function here. So lambda x colon. Then what you have to do in order to fix the negative values, you have to use absolute function. So write absolute of x if x is greater than 0, else x. So this is how you fix a negative values inside a column by using the absolute function. Once this thing is done, what you have to do, just run this out and you can verify this thing again. So let me just run df dot price dot describe. So we can see that here. I think we have done something wrong. So let me just see what. Okay, so here it is x less than 0. Now we can see that we don't have any negative values present in price column. So this is how you solve the problem of negative values inside a column. So this is my step 4. Once this step is done, the next step that we have to do is check for the missing values. So step number 5, check for the missing values. So how do you check for the missing values? Let us see. So first of all, what you have to do, you have to use this function called as df dot is any dot sum. So with the help of this function, we can get the count of missing values. So we can see that there are many columns which contain missing values here. Now the question is how to solve this problem. So there are many ways to solve this problem. One of the basic approach that we use is, let me just write it down. For the numerical column, we use we use mean for that column. And for the categorical column, we use mod for that column. So this is one of the basic approach for dealing with missing values. There are many more other approaches also. For example, you can use k nearest neighbor algorithm for dealing with missing values. And if your data set is time series, what you can do, you can perform backward filling or forward filling or using interpolation method. So these are the techniques that you can use in order to deal with the missing values. Now, in this case, what I'm going to do, I'm just going to fill the missing values with the mean. So first of all, what I need to know is I have to select all the numerical column. So in order to select all the numerical column, what you have to do, you just have to write like this: numerical underscore calls df dot select underscore d types. Now here you have to write include is equals to number. So let me just print out all the numerical columns here. Okay, let me just write numerical calls. So this is selecting all the numerical column. Now what I have to do, I have to replace the missing values with the mean. So let me just iterate through all the numerical column. So df my numerical columns is equals to df numerical column dot fill na. Now in the fill na, what you have to do, you have to take the mean. So df of numerical columns dot mean. So this is the thing you have to do in order to fill out all the missing values in the numerical column. Okay, so what we have done wrong, let me just check it out. Okay, so what you have to do, you just have to write here dot columns dot to list. Now let me just run this out. Now once this thing is done, now you can run this out. Now you can see we have filled our missing values in the numerical column with mean. Similarly, you have to fill the categorical column using mode. So what I have to do, I just have to write here categorical column. So let me just write here categorical columns. So you have to write include is equals to object. So once this thing is done, you have selected all the categorical column. Now, in order to fill the categorical column, what you have to do? You have to fill the categorical column with mode. So for all in categorical calls, I want to fill with the mode. So for calculating the mode, so let me just write mode value is equals to df column dot mode, and I will take the first value, which is the first index 0. Next, I will fill this out. So df call is equals to df call dot fill na, and here I will write mode underscore value. So this is how you fill the missing values in the categorical column using mode. Now you can verify it out. So you have to do df dot is na dot sum. So we can see that we have solved the problem of missing values. So this is our step number 5. The next step is to check for the duplicate values. So what I'm going to do, I will be writing it step 6. Check for the duplicate values. So whenever you face any duplicate values, so what you can do, you just simply drop that duplicate rows. So in order to check for it, you will be using something called as df.duplicated.sum. So let me write df.duplicated.sum. So we can see we have one duplicate rows. So what I'm going to do, I will just drop out that duplicate row. So I will write df.drop underscore duplicates. So it will drop my duplicate rows. You have to assign it in df. Now you can check this again. And you can see we have solved the problem of duplicate values. So this is for the step number 6. The next step that I am going to do is you have to check for the outliers. So let me just write it out. Step number 7, check for the outliers. So what is an outlier? Let us try to understand. Suppose that you have done a survey on 100 people on their average income. You have find out that 95 people have an average income of $10,000, but 5 of them having income of millions. So we can say that these 5 people will be considered as outlier. Now the question here is it necessary to remove the outlier? So the answer will be, it will totally depend upon the domain that you are working, that you have to handle the outlier or not. Sometimes you don't have to handle the outliers. So you can leave as it is. But in this scenario, what I'm going to do, I will show you how you can detect the outlier and how you can fix them. So first of all, in order to detect the outlier, you will be using something called as box plot. So let me just make a box plot for this. So for I, comma, call in enumerate. Here I'm writing my numerical calls that we have made above. Then I'm creating a box plot. So the library that I'm going to use is Cborn. So you can import it out also. Import Cborn as SNS. X is equals to df of call and you have to write axis also. So axis, because we are here, we are plotting all the numerical columns. So let me just write axis and write here I. So let me just check the spelling. Everything is all right. All right. We have to define the figure size also. So let me just define the figure size. So figure comma axis is equals to plt dot subplots n rows is equals to 2 and n calls is equals to 3. Let me import one more library which we will need, which is matplotlib. So import matplotlib dot pyplot as plt. Now let me just set the axis. Axes is equals to axis dot flatten. So here what I'm going to do, I'm just going to set the title. So axis I dot set underscore title. Now I'm plotting it out. So plt dot title layout and plt dot so. So let me just check it out. Everything is correct or not. So number of rows 2, number of column 3. Now once this thing is done, what you have to do, you have to just run this out. Okay, so here we have what we have done wrong. Okay. So the only thing that we have done wrong here is number of rows written as 2. So we have to write it 3. We can see that the columns like sales contain some outlier, comparison price contains some outlier, and the price column contains some outlier. So in order to fix this thing, what I'm going to do, I'm going to use interquartile range in order to remove the outlier. So how do I do this? First of all, I am going to create a function. So let me just write def remove underscore outliers. Here I will be passing data frame and column name. Now in the interquartile range, the first thing that we have to do is find out first quartile. So let me just write Q1 df column name dot quantile. Here you have to pass 0.25, which is my first quartile. Second thing that you have to do is you have to find your third quartile. So I'm writing Q3 and let me pass the same thing. So here I have to pass 0.75. So you have calculated the first quartile and third quartile. The next step that you have to do is you have to calculate something called as interquartile range. So you have to write IQR, which is equal to Q3 minus Q1. So this is called as interquartile range. After that, what you have to do, you have to calculate something called as lower bound. So the formula for calculating lower bound is Q1 minus 1.5 multiplied by IQR. Similarly, we have to calculate something called as upper bound. So here we have to write Q3 plus 1.5 multiplied by IQR. Now we have calculated our lower bound and upper bound. Now what we have to do, filter out all the rows which have values less than lower bound and greater than upper bound. So I am going to filter the data frame. So df filtered. So df and your column name. So let me just write my column name. So df column name less than equal to lower bound. And what I have to do, ampersand, same for upper bound. So df column less than equal to upper underscore bound. So let me just check it out. Everything is works or not. Okay, so it's done. Now what I will do, I will just return this filtered data frame. So return df underscore filtered. Now let me just run this out. It's run. Now what I will do, I will just call the function. So let me just call the function. Df is equals to remove underscore outlier. I have to pass my data frame. And second thing that I have to pass is the column name. So I have the sales column. So let me just run this out. So it's done. Similarly, we have to repeat it for comparison price, comparison sales. So comp price basically. So comp price and one more column we have to do it for pricey also, which is basically the price column. So price and run this out. Now we have cleaned our outlier from the data frame. Now we have talked about outliers. Let us talk about something else which is called as feature engineering. So let me give a heading. Feature engineering. So let us understand what do you mean by feature engineering. Feature engineering means you are going to create new column with the help of existing column present in the dataset. So what I'm going to do, I will be going to create a sales category column based on the sales column. So the first thing that I need to do is to define the range. So breaks. So 0 to 5, 5 to 10, 10 to 15. Then I will define my classes here, which is basically the labels. So there will be three labels: low, medium, and high. So from 0 to 5, it will be considered as low. From 5 to 10, it will be considered as medium. and from 10 to 15, it will be considered as high. Now, with the help of pandas.cut function, I am going to create a new column. So first of all, I will put my column name here. So my new column name will be sales category. Then I'm going to use pandas.cut function. I will specify the column name data which I am using. So df sales. Then I will specify my breaks. So beans is equals to breaks. Then I will specify my labels. So labels is equals to labels. And then one more parameter, which is right equal to false. So this is how you are going to create a new column. So let me run this out. So here we can see it is giving me a key error called as sales. So what I have done wrong is basically this is will capital S and this is done. So let us check. So with the help of head function, we can see the top 5 rows. And here we can see we have a sales category column created. Now the next step will be to check for the data imbalance in the target column, which is our sales category. So let me give a rating. Checking for the data imbalance. So to check for the data imbalance, what we can do, we can use bar plot. So let me take my column name df dot sales underscore category dot value underscore counts dot plot kind equal to bar. Now let me give the title also plt dot title distribution of target column, and then I'm going to show the graph with the help of plt dot show method. So here we can see we are getting our graph, which is distribution of target column. From this column, we can say that medium class has more number of sample as compared to low and high class. So there is a clear sign of data imbalance in it. You can also here specify the bar h also, means bars in horizontal mode. You can also do that. So that will be also fine. Now the thing is how we can solve this issue, like how we can solve the distribution of target column. So there are two techniques to solve it out. First of all, we have something called as undersampling. Then we have oversampling. Let us understand each one by one. Suppose that in a class there are 100 students, 70 of them are boys, 30 of them are girls. So undersampling says that remove the samples from the majority class. So I will remove 40 boys from the class so that it will become 30 boys and 30 girls. So here what we do, remove the samples from the majority class. Now in oversampling, what happened? Let us say we have 70 boys, 30 girls. So what we will do, we will add 40 more girls so that it will become equal, like 70 boys and 70 girls. So here we are doing adding the samples to the minority class. That will be called as oversampling. So this is how you solve the problem of data imbalance. Let me apply undersampling in this experiment. So first of all, what you have to do, you have to import one library which is called as imbalance. Imbalance means imbalance learn. So from imbalance dot undersampling, import random under import random under sampler. Now let me check the distribution of target column, which is df dot cells underscore category dot value underscore counts. So this is my distribution. Medium is 245, low is 77, high is 74. Now let me apply my undersampler. So first of all, I will initialize my random undersampler. So here I will write random undersampler, and in I will pass one parameter which is called as random state. Random state 42. Next, I will be going to perform undersampling. So first of all, I will define my input feature, which is x underscore resampled. Then I will define my target column, which is y underscore resampled. Then I will use undersampler dot fit underscore resample. Then here I am going to specify my input feature. So all the column except the cells category column. So what I will do, I will write df dot drop cells underscore category comma x is equal to 1. Then I will specify my target column, which is df cells category, and this is done. Next, what I am going to do, I will be going to combine my resampled features and the target variable. So for that, I am going to use something called as pd dot concatenation function. So here df underscore resampled equal to pd dot concat. Now pd dot data frame. Here you will to apply x underscore resampled. Then after that, I'll be writing pd dot data frame, and here I will specify my target column, which is cells underscore category. Okay, here we have to use dictionary here. So cells underscore category colon y underscore resampled. Then I will specify comma x is equal to 1. So this is how we are going to apply random undersampling. Now let me run this code. Here we can see we have done one spelling wrong. So let me fix it out. Now we can see our code has successfully run. Now let us check the distribution of the cells category column. So what I'm going to do, I will be writing df underscore resampled dot cells underscore category dot value underscore counts. Let me check what is giving it. Data frame has no object cells underscore category. Okay, so here we can see that we have done spelling wrong here. Category. Let me just check any other thing. Everything is okay. Let me just run this out. Let me run this out. You can see that now my code is successfully run, and we can see that all the problem of data imbalance has been solved out. Like all the values are now 74, 74, 74. So this is how you can solve the problem of data imbalance. There is another way which is called as oversampling. So what you have to do in this code, instead of random undersampler, you have to use something called as random oversampler, and then here instead of random undersampler, just replace it with oversampler. That's it. Rest everything will be same. So this is how you solve the problem of data imbalance. Next, we will be going to check for the skewness in the numerical column. So checking for the skewness. Before that, let me talk a little bit about theory related to skewness. Here we can see if the distribution of numerical column have zero skewness, we can say that data is normally distributed. If all the data points is on the right hand side, we can call it as left skewed distribution. And here, if all the data points is on the left hand side, we call it as right skewed distribution. So these are three types of skewness or three types of distribution we have. Right skewed, normal distribution, and this is called as left skewed distribution. We have one more type of distribution which is also called as uniform distribution. Means every values will be equal at each level. Let us see the graph for uniform distribution also. So here you can see that this is the graph for uniform distribution. So here all the values will be same for each point. This thing is called as uniform distribution. Now let us try to implement this out. So we know that if values on the left hand side, most values on the left hand side, so it will be a right skewed distribution. Similarly, if values on the right hand side, it will be left skewed distribution. And if all the values lies in the middle, so we have a normal distribution. And if the values are constant across every point, so we call it as uniform distribution. So these are mainly four types of distribution we have. Now let us see the practical. So first of all, what I'm going to do, I'll be going to create an histogram in order to check for the skewness. So let me specify my figure. Then I will specify my axis because I'm going to make a subplot here. So after that, I will be using plot.subplot function. Here I'll be going to define number of rows and number of columns. So n rows equal to 2, n calls equal to 3. So this number you can choose it based on how many numerical columns you have. In my case, we only have 5 numerical columns. That's why I'm going to use 3, 2. Then next we have to specify something called as figure size. So fig size, and here I'm specifying the figure size at 16, 8. Here 16 is the width and 8 is the height. Next, I will specify my axis. So axis dot flatten. So it will flatten out our axis. Then I'm going to use enumerate keyword. So if you remember, in Python, enumerate means it will give us index position and its corresponding value. So we will write for I, j in enumerate. Then I will specify my column names. So my column names is basically numerical calls. So numerical calls that I have defined previously. After that, we will be going to write sns dot histplot df underscore the resampled. Then I will specify here j, comma, axis. So x is equals to axes I. And then we are going to specify one more thing which is called as kernel density estimation, KDE. equal to true. Once this thing is done, let me plot it out. X is I dot set underscore title. So here I'm setting the title of the graph. So once this thing is done, I'll be going to use tight layout, and I'm going to use show function. So this is basically how you can make a histogram subplot. Now here you can see we are getting an error. So basically plt dot subplots you have to write, and you can see rest everything is fine. Now we have sales column, comparison price, income, advertising, and population column. So these are the 5 numerical columns we have present. So first of all, let us understand what is sales column. So here you can see most values is a little bit on the left side of the graph. So we can say that this graph has nearly right skew distribution. Now we have comparison price. So in comparison price, we can see that values mostly lies in the middle. So it looks like it is following nearly a normal distribution. Here we can see income. In income, most of the values is falling on the right hand side. So we can call it as left skewed distribution. In advertising, most values on the left hand side. So it is called as right skewed distribution. And population, we can see that most values is on the right hand side. So we can call it as left skewed distribution. So this is how you can determine it out. Now the question is how to solve the problem of skewness. So in order to solve the problem of skewness, we use something called as logarithmic. So what we will do, we will apply log to that column. So let me take the dataset frame. So df underscore resampled, and here I'm going to apply it on sales column. So let me create a new column which is called as sales log, and after that I'm going to use numpy library np, then I'm going to use log, so log 1p, then my column name. So let me take my column name and paste it here. Here I'm going to use sales column. So this is how you can solve the problem of skewness in your numerical column. So let me just run this out. Next, what we are going to do, we will be going to check for the correlation. So here what we are going to do, let us talk about correlation. Correlation means association between two or more variables in the data set. So we have 3 types of correlation particularly. First of all, we have positive correlation, then we have negative correlation, and then we have no correlation at all. You can say zero correlation. So we have positive, we have negative correlation, and we have something called as zero correlation. The values range in -1 to 1. Let us understand what do you mean by positive correlation with the help of an example. Suppose that your work experience is increasing, so your salary will also get increase. So here what happen, if one variable is increasing, the other variable will also increase. So this is called as positive correlation. So year experience versus salary. Next we have negative correlation, means one thing is increasing, so the other thing is decreasing. Think like as a supply and demand. So if we have a more supply of Bitcoin, then the demand will be less. But if we have less supply of Bitcoin, then demand will be more. That thing is called as negative correlation. So this is a supply and demand. After that, we have a zero correlation. Zero correlation means they the variables are not related to each other. For example, height of a mountain and height of a man. There is no correlation between them. That's why it is called as zero correlation. Now, in order to check, so first of all, we have to define our numerical variables. So num underscore df underscore resampled dot select. Here I'm going to select all the numerical columns. Include to. First of all, we have integer column, and then we have float column. So it will select all the numerical column which is present in our data set. Next, what we will do, we will check for the correlation. So let me make a correlation table here. So I'll be going to do num underscore df dot core. And I'm going to store it in a variable called as cm, which is correlation matrix. And let me plot the cm. Here you can see this is my correlation table. Currently it is in tabular format. So what I can do, with the help of cbol library, I can plot a correlation graph. So let me make a correlation graph here. So first of all, I am setting the figure size. plt.figure fixed size equal to, let me just specify something called as 10,8. Yeah. Then I'm going to use heat map, sns.heatmap, and here I'm specifying my correlation matrix, which is cm. Then I'm going to specify annotation is equals to true. Basically, it will show the numerical values also, like what is the correlation between two variable. Then I'm going to set some color map, basically the style. So cmap equal to cool, warm. After that, I'm going to use format function, and here I want the values, correlation values up to 2 decimal places. So I'll write 0.2f. Then I will write comma square equal to true. Means values will show in square format. Okay. Then I'm going to give title correlation matrix plt dot show function. Here you can see it is giving me my correlation matrix graph. So let us see how we can interpret this thing. If you can see, the diagonal element means the correlation between cells and the column itself is having correlation value of 1. Now we can see something like cells, and here cells log. It has a correlation value of 0.95. Similarly, comparison price, the correlation with price is 0.52. So this is how you can interpret the graph. If the values are greater than 0.5, you can say that it is strongly positive correlated. If it is between 0.25 to 0.5, it is called as moderate positive correlation. And if the correlation value is less than 0.2, like 0 to 0.2, it is called as weak positive correlation. And if it is 0, it means we have zero correlation at all. And if it is negative, we call it as negative correlation at all. So this is how you can interpret the correlation matrix. So the values above the diagonal will be called as upper triangular matrix, and the values below the diagonal is called as lower triangular matrix. Now the thing is, this particular values will be called as Pearson correlation matrix. So this is the Pearson correlation value. Now from the correlation matrix, you can solve one problem which is called as multicollinearity. Multicollinearity. So let us understand what do you mean by multicollinearity. When the correlation between two variables is very high, like let us say greater than 0.7, it will be called as multicollinearity problem. Take a simple example. Suppose that we have a political party and it is getting too much funding from outside. So the foreign companies can impact the decision of that political party, or they can bias the decision. So that's why we need to solve the problem of multicollinearity. We cannot have very high correlation between two variables. So in order to solve this thing, what we will do first of all, we will find the highly correlated pair, like which columns are having high correlation. So this is the code that I'm going to use. So first of all, I will be defining my threshold, which is 0.7. Then I'm going to find my highly correlated pair. So CM greater than threshold and CM less than 1. So this is where we can find the highly correlated column pair. After that, I will print them out. Now here you can see, we can see that column cells and cells log are having very high correlation with each other, 0.95 correlation value. So in order to solve the multicollinearity problem, what we can do, we can remove one of this column. So let us remove one of this column, which is cells log. I am defining which columns to drop. Then I am iterating over highly correlated column pair. Then I am finding that column and dropping it out. So this is how you can do that. Now, by this way, we can solve the problem of multicollinearity. Next, feature cardinality means number of unique values in the categorical column. So if we have too many number of unique values in the categorical column, we can say that it is very high cardinality. And second thing, if we have very less number of unique values in the categorical column, that thing will be called as low cardinality values. Now let us implement this feature cardinality in our dataset. So first of all, what I'm going to do, I'm going to select all the categorical column present in my dataset with the help of select_dtypes function. Once we have selected all the categorical column, we will check for the cardinality for each categorical column, like unique values for each categorical column. So for that, I am using something called as nUnique function. nUnique means number of unique values in that column. After that, what I'm going to do, I'll be going to printing out all the cardinality values. So here we can see that I am printing their feature and their unique count in basically cardinality. Now here you can see that self-block has 3 unique values, urban has 2 unique values, and US has 2 unique values. So this is how you check for the feature cardinality. We can see that there are not too many unique values or very less unique values. So we can say that in our data set, there is no problem of feature cardinality. Next, there is something called as label encoder. So let us understand, what do you mean by label encoder? Label encoder is basically a process of converting the categorical column into the numerical column. For example, suppose that we have a column named as color and it contains 3 unique values, red, blue and green. So label encoder, what it will do, it will give numerical values to these 3 columns. Like red will become 0, blue will become 1 and green will become 2. So this thing is called as label encoder. So in order to implement label encoder, we can use this below Python code. So first of all, I am iterating through all the column. If the column nature is object or in a categorical format, we basically convert them in a category and then we will perform cat.codes function. So let me run this out. After that, we can use head function to check the values
whether it is encoded or not. So you can see that now my all the categorical values like cell block, urban US and cells category is converted into the numerical format. So this is what we call it as label encoder. So this is all about data preprocessing using Python programming. Hope you will like it. So if you enjoyed, just do like and subscribe to our YouTube channel.